November 12th, 1942, Richmond, California. A complete cargo vessel, 441 feet long and weighing 14,245 tons, stood ready to slide into San Francisco Bay through the gates of Permanente Metals Corporation, Yard Number 2. The ship had been assembled in just 4 days, 15 hours, and 29 minutes. In traditional shipyards, master builders had spent 6 to 8 months constructing vessels of similar size since before the American Revolution. Yet here, a complete Liberty ship stood ready for service. Over 1,000 workers stepped back from the hull of the SS Robert E. Peary, not traditional shipwrights, not experienced maritime craftsmen, but former secretaries, farmers, housewives, and labourers who had learned welding techniques just weeks earlier. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The crowd of officials, journalists, and competing shipyard owners had gathered to witness a moment that would trigger a profound transformation in industrial production, a systematic revolution through American manufacturing innovation that would echo across decades. The mathematics of Allied victory were being written not in battle strategies, but in production statistics that would shatter every assumption. Maritime experts carried about shipbuilding limits, construction timeframes, and industrial possibility. What made this moment even more remarkable was that just 2 years earlier, the man responsible for this revolution had never built a single ship. The transformation had begun on December 27th, 1940, when Henry J. Kaiser signed his first shipbuilding contract, a man who had never built a ship, never managed a shipyard, and had spent his career moving earth and pouring concrete for massive dam projects across the American West. Yet here stood a 58-year-old construction magnate who had just promised the United States Maritime Commission he would build 30 cargo vessels for the British government within 2 years. Traditional shipbuilders dismissed him as a naive opportunist. The Todd Bath Iron Works, one of America's oldest shipyards, had reluctantly agreed to partner with Kaiser on the project, assuming their expertise would compensate for his ignorance. What none of them understood was that Kaiser's lack of shipbuilding experience would become his greatest advantage. He carried no assumptions about what couldn't be done, no reverence for traditional methods simply because they had always been done that way, and no fear of challenging centuries of accumulated maritime wisdom. Among those watching Kaiser's first steps into shipbuilding was William Francis Gibbs, America's most respected naval architect, whose firm Gibbs and Cox had created the Liberty ship plans based on British designs. Gibbs had designed more ships than Kaiser had probably seen. He represented everything the maritime establishment valued: technical precision, comprehensive knowledge, respect for traditional craftsmanship, and decades of proven expertise. Kaiser represented something different entirely: the audacity of inexperience combined with the confidence of someone who had already accomplished what others considered impossible in other industries. The contrast between these two men symbolized the coming collision between tradition and innovation that would reshape American industrial capability. The journey from skepticism to revolution began in the planning offices of Todd Shipyards in New York. As Kaiser and his engineers examined traditional shipbuilding procedures in early 1941, they recognized immediately that conventional methods would never meet wartime demands. The crisis facing America and Britain was not abstract or theoretical. German U-boats were hunting Allied shipping across the Atlantic, with devastating effectiveness. In 1940 alone, German submarines and surface raiders had sent over 4 million tons of Allied shipping to the ocean floor. Britain, dependent on imported food and materials for survival, was literally starving. The mathematics were brutally simple. If ships sank faster than they could be replaced, Britain would be forced to surrender regardless of military courage or strategic brilliance. Kaiser's chief engineer, Clay Bedford, had visited a Ford Motor Company assembly line in Detroit just weeks before beginning the shipyard planning. Bedford had watched automobile chassis moving down production lines with workers installing prefabricated components at each station. Each worker performed a specific task repeatedly, becoming extraordinarily efficient at that single operation. The chassis moved systematically from station to station, with complexity building incrementally until a complete automobile rolled off the end of the line. Bedford had returned to California convinced that ships could be built the same way. The traditional shipbuilders considered this comparison absurd, offensive even. Maritime construction required precision that automotive assembly could never match. The ocean was unforgiving. A defective car might break down on a highway. A defective ship would sink with its crew. But Bedford and Kaiser saw something the traditional builders missed. The fundamental principles of assembly line production, breaking complex tasks into simple, repeatable operations, using prefabricated components, organizing workflow for maximum efficiency, applied to any manufacturing process regardless of the final product's size or complexity. The question wasn't whether ships could be built like automobiles. The question was whether the maritime industry's resistance to manufacturing principles stemmed from legitimate technical concerns or simply from institutional inertia and resistance to change. Kaiser believed the latter. He was prepared to stake his reputation and fortune on proving it. The first real shock came with Kaiser's proposal to eliminate riveting entirely. Traditional ship construction relied on rivets, heated metal pins that were hammered through overlapping steel plates to join them together. A skilled riveting crew, working with perfect coordination and years of experience, could install perhaps 100 rivets per day. The process required tremendous skill. Riveters worked in teams of 4, a heater who brought the rivet to precise temperature, a catcher who positioned it, a bucker-up who held a heavy iron bar against one end, and a riveter who hammered the other end into a permanent joint. Each Liberty ship required approximately 1 million rivets if built conventionally. Even with multiple crews working simultaneously, the riveting process alone would consume months of construction time. Kaiser proposed using electric arc welding instead, a technique he had mastered building pipelines and dams across the American West. Welding joined metal pieces by melting them together, creating a continuous bond rather than thousands of individual mechanical fasteners. The process was faster, required less skilled labor, and produced lighter structures because overlapping plates were unnecessary. But welding also carried risks that terrified traditional maritime engineers. Welded joints could fail catastrophically if done incorrectly. A bad rivet might leak or loosen. A bad weld could fracture suddenly under stress, potentially breaking a ship in half. The British Royal Navy, the world's most experienced maritime power, had tested welding extensively and forbidden its use on warship hulls for precisely this reason. Vice Admiral Emery Land, chairman of the United States Maritime Commission, examined Kaiser's proposal with deep skepticism. His private correspondence, preserved in the National Archives, revealed the maritime establishment's reaction with brutal clarity. Land wrote to a colleague in January 1941, "Welding has never been proven reliable for hull construction at this scale. The British Navy forbids welding on warship hulls after their trials demonstrated unacceptable risk of catastrophic failure. Kaiser is proposing we bet America's supply lines on an unproven technology. If these ships break apart in Atlantic storms or under torpedo attack, the consequences will be measured in thousands of lost lives and potentially the outcome of the war itself." Yet Land also recognized desperation. German U-boats and surface raiders were sinking Allied shipping faster than traditional shipyards could possibly replace vessels. In 1941 alone, approximately 3.6 million tons of Allied shipping would go to the ocean floor from all causes: enemy action, accidents, storms, and mechanical failures. Britain was literally starving. Rationing had been implemented across the island nation. Food stocks were measured in weeks rather than months. The British government's classified assessments, later declassified in the 1970s, estimated that Britain could sustain the war effort for perhaps 6 more months if shipping losses continued at current rates and replacement production remained at traditional speeds. American shipyards, using conventional methods, would require an average of 230 days to build a single cargo ship. Some yards, particularly those on the East Coast with older facilities and more traditional management, needed over a year to complete a vessel. At that pace, the Allies would lose the Battle of the Atlantic before American industry could respond. The decision to approve Kaiser's contract represented not confidence in his revolutionary methods, but desperation born of mathematical inevitability. Land approved Kaiser's welding proposal not because he believed it would work, but because he knew traditional methods would certainly fail to produce ships fast enough to matter. The Richmond shipyard rose from empty mudflats between January and December 1941. Kaiser's construction crews, experienced in building dams and highways but completely ignorant of maritime tradition, erected a facility that horrified traditional maritime engineers who visited during construction. Instead of the massive gantry cranes and longitudinal building ways that characterized established shipyards like those in Bath, Maine, or Newport News, Virginia, Richmond featured something entirely different. The yard was laid out like an automobile assembly plant. Open areas for prefabrication surrounded 7 parallel building ways. Railroad tracks crisscrossed the facility, designed to move massive steel sections weighing up to 150 tons. Overhead cranes capable of lifting entire ship sections stood every 100 feet. John Riley, Chief Naval Architect for Bethlehem Steel Corporation and a 30-year veteran of IRA's shipbuilding, visited the Richmond yard in May 1941 while the facility was still under construction. His inspection report, marked confidential at the time and later discovered in Bethlehem Steel's archives, contained both technical criticism and grudging admiration that revealed the cognitive dissonance traditional experts experienced confronting Kaiser's approach. Riley wrote, "Kaiser has violated every principle of efficient shipyard layout I learned in 3 decades of experience. His prefabrication areas are too large, wasting valuable waterfront space. His crane capacity is absurdly excessive. No shipyard needs this much lifting capability. His building ways are too short for efficient longitudinal construction. The railroad infrastructure is unnecessarily elaborate. Yet I must admit, with considerable reluctance, that the facility is designed perfectly for exactly what he claims to accomplish: rapid assembly of prefabricated sections rather than traditional keel-to-deck construction." Riley's report continued with an observation that captured the fundamental difference in philosophy. Traditional shipyards are designed for craftsmanship. Kaiser's yard is designed for manufacturing. Whether ships can actually be manufactured rather than crafted remains to be seen. I am skeptical, but I confess Kaiser's confidence is unsettling. He speaks with the certainty of someone who has already succeeded, rather than someone attempting something unprecedented. The arrival of workers provided the next phase of revolutionary change that would challenge every assumption the maritime industry held about skill, training, and expertise. Traditional shipyards recruited from established maritime communities where skills passed from father to son across generations. Young men entered shipyards as apprentices in their teens and spent years learning comprehensive skills under the guidance of master craftsmen. A traditional shipyard worker was expected to understand ship design principles, read complex technical drawings, work with multiple materials and tools, and make independent judgments about construction methods. This comprehensive skill set took years to develop and represented the accumulated knowledge of centuries of maritime tradition. Kaiser rejected this entire approach. He advertised in newspapers across America, offering wages 20% above standard industrial rates and promising to train anyone willing to work. The advertisements appeared in farm journals, women's magazines, and small-town newspapers in communities that had never seen an ocean. Kaiser's recruiters sought workers not from maritime tradition but from agricultural communities, from factories that had closed during the Depression, from anywhere people needed work and possessed basic competence. The first groups arrived in Richmond in August 1941, farmers from Oklahoma and Arkansas who had lost land during the Dust Bowl, factory workers from closed mills in Pennsylvania and Ohio, women whose husbands had enlisted in military service, African Americans from southern states seeking opportunity in Western industries, young people barely out of high school with no work experience at all. They came in buses and trains, carrying belongings in cardboard suitcases, arriving at a massive industrial facility on San Francisco Bay to build ships despite having no conception of what shipbuilding actually involved. Traditional shipyard managers who visited Richmond during this period predicted immediate failure. The workforce was absurdly unprepared. Success was impossible. Kaiser's training program revealed the power of his manufacturing philosophy applied to human capability. The simplification of complex tasks into repeated simple operations, borrowed directly from assembly line manufacturing, proved devastatingly effective. Traditional welders spent 4 years as apprentices learning comprehensive skills. How to weld vertical, seams and horizontal seams and overhead seams, how to work with different metals and thicknesses, how to judge heat and speed and electrode angle, how to inspect their work and correct defects. Kaiser's instructors taught specific techniques for specific tasks in approximately 2 weeks. Workers didn't need to know how to weld everything, only how to weld the vertical seams on bulkheads or horizontal deck plates or curved hull sections, whichever specific task they would perform repeatedly on the assembly line. A worker might spend weeks doing nothing but welding the same seam on bulkhead after bulkhead. That worker would become extraordinarily proficient at that single operation while remaining completely ignorant of overall ship construction. This violated every principle traditional craftsmen held sacred. How could someone call themselves a shipbuilder if they only knew how to perform one small operation? Kaiser's answer was simple. They weren't shipbuilders. They were manufacturing workers building ships. The distinction mattered enormously. Traditional craftsmen took pride in comprehensive knowledge. Kaiser's workers took pride in exceptional performance of specific tasks. By October 1941, Kaiser employed over 10,000 workers in Richmond, with fewer than 200 having any previous maritime experience. Traditional observers predicted chaos. How could 10,000 untrained workers possibly coordinate to build something as complex as a ship? The answer emerged through the autumn of 1941, as Kaiser's first Liberty ships began taking shape on the building ways. The workers didn't coordinate. The system coordinated them. Each worker performed specific tasks at specific times in specific locations. The complexity existed in the organization, not in individual workers' knowledge. A farmer from Oklahoma, who had never seen a ship 3 months earlier, now welded bulkhead seams with precision that matched experienced craftsmen, because he had welded the same seam 200 times and received immediate feedback on quality from inspectors who checked every weld. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. As workers gained experience through late 1941 and early 1942, something unexpected occurred that even Kaiser had not fully anticipated. The construction time for Liberty ships began falling dramatically, not through incremental improvement but through cascading acceleration. Kaiser's first Liberty ship took 197 days to build and deliver, faster than traditional yards but still measured in months rather than weeks. Ship number 2 required 169 days, a reduction of 28 days despite being essentially identical in design. Ship number 5 required 128 days. Ship number 10 required 97 days. By spring 1942, Richmond was completing Liberty ships in 70 days on average, less than half the time traditional shipyards required. Traditional shipyards watched with growing alarm as this untrained workforce achieved production speeds that matched, then exceeded, their own highly skilled crews. The explanation violated everything maritime tradition taught about skill and expertise. Kaiser's workers were learning faster than traditional craftsmen because they performed specific operations repeatedly rather than learning comprehensive skills slowly. A traditional apprentice might practice a particular welding technique occasionally over 4 years while learning dozens of other skills. Kaiser's worker performed the same weld hundreds of times in weeks, achieving mastery through focused repetition. The learning curve was dramatically steeper because the task was narrower. The prefabrication approach that traditional builders had dismissed proved its power through the winter and spring of 1942. Instead of building ships from keel to deck in sequence, Kaiser's yards fabricated entire sections simultaneously across the facility. While one crew assembled a bow section in the prefabrication area, other crews built stern sections, deck houses, engine rooms, and bulkheads in parallel. When sections were complete, massive cranes lifted them onto the building ways where welding crews joined them together. The process resembled assembling a massive three-dimensional puzzle rather than constructing a ship from bottom to top. Albert Wooding, production supervisor at Richmond Yard No. 2, explained the efficiency in a 1943 interview with Fortune magazine that captured the fundamental difference in approach. In traditional shipbuilding, you cannot install the engine until the engine room is built. You cannot build the engine room until the hull is complete. You cannot complete the hull until all frames are in place. Everything happens in sequence, each step waiting for the previous step to finish. Kaiser's approach allows parallel production. While one crew welds hull plates, another crew assembles the engine in a separate workshop area. While a third crew builds the deck house, a fourth crew fabricates bulkheads. When all components are ready, we assemble them in hours rather than weeks. Tasks that previously required weeks now take hours because we eliminated the waiting. The statistics of parallel production revealed manufacturing efficiency that seemed impossible to traditional builders who studied Kaiser's operations with increasing desperation through 1942. A conventional shipyard might have 50 workers attempting to install an engine over 3 weeks, working in the cramped confines of a partially complete engine room, maneuvering heavy components through narrow openings, fighting limited access to perform each installation step. Kaiser's prefabrication approach assigned 200 workers to assemble the complete engine and its mounting structure in an open workshop over 5 days, then used cranes to position the entire assembly in a single 8-hour operation. The mathematics were inescapable. 200 workers for 5 days equaled 1,000 worker days, while 50 workers for 3 weeks equaled 1,050 worker days. Nearly identical labor investment but dramatically different results because the open workshop allowed efficient work while the cramped engine room forced inefficiency. More disturbing still to traditional maritime authorities was the casual elimination of centuries-old shipbuilding practices that had been considered sacred and unchangeable. Ships had always been built from carefully drafted plans that specified every detail, every measurement, every material specification documented in drawings that took months to produce. Kaiser used simplified drawings that provided basic dimensions and left details to workers' judgment. Traditional builders considered this recklessness, bordering on criminal negligence. Kaiser called it flexibility and common sense. If a worker encountered a situation where the simplified drawing proved inadequate, they consulted a supervisor who made an immediate decision, no waiting for engineers to revise drawings. No delays while technical offices debated proper solutions. Problems were solved in minutes rather than days. Vice Admiral Howard Vickery, Vice Chairman of the Maritime Commission and a career naval officer who had spent decades in traditional naval construction, initially fought against Kaiser's simplified specifications with the passion of someone defending fundamental principles. His transformation from skeptic to supporter, documented in commission meeting minutes preserved in the National Archives, illustrated the power of results over theory with brutal clarity. In January 1942, Vickery wrote in a memo to Admiral Land, "I opposed Kaiser's request to reduce drawing specifications during our meeting yesterday. Ships are not automobiles. Maritime construction requires precision that automotive manufacturing does not. The ocean is unforgiving. Simplified specifications will lead to defects that will cost lives." But by March 1942, Vickery's tone had changed noticeably in official correspondence. He wrote, "Kaiser's yards are now outproducing our traditional contractors by 40%. I do not understand how this is possible with his simplified methods, but the ships pass inspection and enter service successfully." By June 1942, Vickery had become a reluctant convert, writing with the resignation of someone whose fundamental beliefs had been proven wrong by undeniable evidence. The gap has widened to 70%. Kaiser's yards produce 17 Liberty ships monthly, while our traditional contractors produce 10 ships monthly despite having more building ways and longer experience. I have learned that perfection is the enemy of sufficient. Kaiser's ships are not beautiful, they are adequate, and adequate ships delivered in July carry more cargo than perfect ships still under construction in December. As construction speeds increased through spring and summer 1942, competition developed among Kaiser's 7 shipyards spread across California, Oregon, and Washington. His son, Edgar, who served as vice president and general manager overseeing all Kaiser shipyards with particular focus on the 3 Pacific Northwest facilities, managed the Oregon Shipbuilding Corporation in Portland. Clay Bedford oversaw the Richmond yards in California. The 2 men, both driving and ambitious, began an informal contest to see whose facility could build ships faster. The competition was not officially sanctioned by Kaiser Sr., but he did nothing to stop it, recognizing that the rivalry drove both facilities to achieve extraordinary performance. The race between Richmond and Portland became a public spectacle through fall 1942. Newspapers published updates like sports scores, tracking which yard held the current speed record and by how many hours. Local radio stations in both cities broadcast daily progress reports during record attempts. Workers at competing yards followed the rivalry intensely, taking personal pride in their facility's performance. Competition records fell repeatedly through September and October 1942 until Oregon Shipbuilding built the Joseph N. Teal in just 10 days, an achievement that stunned even Kaiser himself. Vice Admiral Vickery eventually ordered the speed competition stopped in November 1942, declaring them stunt demonstrations that distracted from actual production goals and potentially compromised quality in pursuit of publicity. But the competition had served Kaiser's purpose brilliantly. Workers across all 7 yards now believed that extraordinary speed was not merely possible, but expected and normal. The psychological barrier that had convinced people ships required months to build had been shattered. If one yard could build a ship in 10 days, why couldn't every yard build ships in 15 or 20 days consistently? The competition had transformed workers' understanding of what was achievable, which proved more valuable than any amount of training or motivation could have accomplished. Seeing the impossible become routine changes how people think about limitations. November 1942 brought the ultimate demonstration that would cement Kaiser's reputation and force complete capitulation from traditional maritime authorities. Vice Admiral Land, visiting Richmond to inspect production, made an offhand comment to journalists that was overheard by Clay Bedford. The Admiral remarked that Liberty ship construction had improved remarkably from the dark days of 1941, but noted that the recent speed records still paled, compared to what mass production had achieved in other industries. Automobile factories produced complete vehicles in hours, not days. If shipbuilding was truly manufacturing rather than craftsmanship, why did ships still require over a week? Bedford took the comment as a challenge that struck at the core of Kaiser's entire philosophy. He proposed to Vice Admiral Land that Richmond Yard No. 2 would attempt to build a complete Liberty ship from keel laying to launch in under 5 days, cutting the Joseph N. Teal's record in half and proving definitively that ships could be manufactured as rapidly as any other industrial product. Land, skeptical but intrigued by Bedford's confidence, authorized the attempt on condition it not disrupt regular production schedules. The other 6 building ways at Richmond Yard No. 2 would continue normal operations. Only building way No. 1 would attempt the record. Bedford selected the hull to be named SS Robert E. Peary, after the Arctic explorer for the record attempt. Starting Sunday, November 8th, at 1 minute past midnight, over 1,000 workers operating in carefully coordinated shifts would attempt something unprecedented in maritime history. The prefabrication strategy that Kaiser had developed over 18 months reached its ultimate expression during the Peary construction. Every major component had been built, inspected, and staged before the keel touched the building way. The bow section, comprising more than 50 individual pieces, had been fully welded and equipped with anchor hardware, chain lockers, and forward crew quarters before assembly began. Workers could walk through the bow section while it sat in the prefabrication area, a complete functional unit waiting to become part of a ship. The stern section included the completed steering gear, propeller shaft, and aft crew spaces, fully wired and plumbed. 4 complete cargo holds, each one a massive rectangular structure of steel that weighed over 100 tons, stood ready to be lifted into position. The engine, a 140-ton triple-expansion steam power plant built by Joshua Hendy Iron Works in Sunnyvale, had been mounted on its foundation structure and test-fired before leaving the factory. Where conventional shipyards built from keel to deck over months, assembling millions of individual pieces in sequence, Kaiser's yards assembled a nearly complete ship from prefabricated sections in days, joining perhaps 50 major components, rather than manipulating millions of small parts. 4 days into construction, the hull was complete, a functional ship in all essential aspects, engine installed and tested, deck houses positioned and secured, cargo holds in place with hatches operational, steering gear mounted and connected to the bridge controls, electrical systems energized and functioning, plumbing systems pressurized and inspected for leaks. On Thursday, November 12th, at 3:30 in the Pota afternoon, just 4 days, 15 hours, and 29 minutes after the keel touched the building way, SS Robert E. Peary slid down the launching rails into San Francisco Bay. The ship was delivered for final outfitting and acceptance trials on November 15th, setting an additional record of 7 days and 14 hours from keel laying to full delivery. The crowd of observers that gathered for the launching included maritime officials, military officers, competing shipyard owners, and journalists from across America and Britain. Many arrived expecting to witness either failure or a compromised vessel that looked complete but lacked functionality, essentially a propaganda stunt. What they saw instead was a fully operational ship that required only minor fitting out before entering service. The vessel passed all maritime inspections. The hull was sound, the welding met specifications, the engine operated properly, every system functioned as designed. Vice Admiral Land, present for the launching, made brief remarks that were recorded by newsreel cameras and later broadcast in theaters across America. His words captured the maritime establishment's forced recognition that everything they believed about shipbuilding had been proven wrong. Land spoke slowly, choosing words carefully as someone admitting a fundamental error. 6 months ago, I would have called this impossible, not difficult or unlikely, but genuinely impossible. Traditional shipbuilding wisdom accumulated over 3,000 years, from ancient Phoenician builders through Roman galleys to modern steel vessels, said you cannot build a proper ship in 5 days. The knowledge required, the skills necessary, the coordination demanded, all pointed to months as the minimum time frame. Henry Kaiser has made traditional wisdom obsolete. The United States Maritime Commission will now require all contracted shipyards to adopt these methods or face contract cancellation. The psychological impact on traditional shipbuilders was profound and immediate, representing nothing less than the collapse of an entire professional worldview. The same yards that had dismissed Kaiser as an ignorant outsider just 18 months earlier now sent engineers to study his approaches with the desperation of students who had failed examinations. The president of New York Shipbuilding Corporation, one of America's oldest and most prestigious yards with a history reaching back to 1899, visited Richmond in December 1942. His confidential report to his board of directors, later discovered in company archives, revealed complete ideological collapse regarding traditional approaches and an almost painful self-awareness of institutional failure. He wrote with remarkable honesty, "Kaiser has achieved what our industry considered impossible by refusing to accept our limitations as real. He treated shipbuilding as a manufacturing problem rather than a craft tradition. He simplified where we sought perfection. He standardized where we customized. He trained masses of unskilled workers where we cultivated generational expertise requiring decades. The result is ships built in 1/10 the time at 2/3 the cost with equal or superior quality by every measure that matters. We must either adopt his approaches completely and immediately or accept irrelevance and bankruptcy. There is no middle path. Half measures will fail." By early 1943, Kaiser's influence had transformed American maritime production completely and irreversibly. 18 shipyards across the country were building Liberty ships using prefabrication and welding. Average construction time had fallen from 230 days initially to just 42 days by mid-1943. The United States was launching 3 Liberty ships every day, more tonnage than German submarines could sink, even during their most successful periods. The mathematics of attrition had reversed completely. In 1941, German U-boats sank ships faster than Allied yards could replace them. By 1943, American production exceeded losses by 3-1. The Battle of the Atlantic was essentially won not by superior naval tactics or better anti-submarine weapons, but by industrial capacity that made losses irrelevant. But perhaps the most devastating challenge to traditional maritime authority came from the quality and composition of Kaiser's workforce, which represented a direct repudiation of centuries-old assumptions about skill, training, and who could perform complex industrial work. The tens of thousands of women, minorities, and untrained workers who had built these ships proved that expertise was not inherent in certain groups, but could be developed in anyone given proper training and opportunity. At peak production, in 1944, Kaiser's 7 yards employed approximately 196,000 workers. Of these, over 40,000 were women, representing a remarkable percentage of female industrial workers in an era when women were expected to remain in domestic roles. By mid-1944, women comprised 27% of Richmond's production workforce, performing every job from welding to crane operation to supervision. The 3 Northwest Kaiser yards in Portland, Vancouver, and Tacoma employed over 31,000 women by 1944. These women were not performing light assembly work or clerical duties. They were welding hull plates, operating massive cranes, fitting steel sections, and managing production schedules. African American workers, numbered in the tens of thousands, employed in skilled positions, including welding, fitting, crane operation, and even supervisory roles. A level of workplace integration unusual for 1940s America. The democratization of skilled work that Kaiser enabled carried implications far beyond wartime production, challenging fundamental assumptions about labor, skill, and human potential. By proving that complex manufacturing could be performed by trained workers rather than requiring generational craft expertise, Kaiser's shipyards opened industrial opportunity to groups that had been systematically excluded. A woman who learned to weld Liberty ship hulls in 1943 carried that skill and confidence into peacetime employment. An African American worker who supervised production crews in Kaiser's yards in 1944 had demonstrated capability that racist assumptions claimed impossible. The social transformation was as significant as the Industrial Revolution. Though less immediately visible, the ships could be counted and measured. The change in human potential and opportunity was harder to quantify, but ultimately more important. The total American maritime production between 1941 and 1945 exceeded 5,500 vessels, representing approximately 53 million tons of shipping. The scale of production was staggering to contemporary observers and remains impressive by modern standards. Commander Joseph Kenworthy of the Royal Navy, assigned to the British Admiralty delegation in Washington, watched American production with admiration mixed with envy and a touch of British pride wounded by American industrial dominance. His official reports to the Admiralty, declassified in the 1980s, captured the British perspective on American industrial capacity with remarkable candor. Kenworthy wrote in March 1944, "The United States is building merchant shipping at a rate that exceeds the combined capacity of the rest of the world, including Britain, Canada, and all neutral nations combined. Kaiser alone produces more tonnage monthly than the entire British shipbuilding industry, with its centuries of maritime tradition. The approaches are crude by Admiralty standards. The ships are inelegant, utilitarian, built for function rather than form, but they float reliably, they carry cargo safely, they withstand Atlantic storms and arrive at destination, and there are thousands of them. The Royal Navy built the finest warships in the world using traditional craftsmanship requiring years per vessel. The Americans build adequate ships in weeks. Adequate multiplied by thousands defeats perfection multiplied by dozens." But perhaps the most remarkable aspect of Kaiser's transformation was what happened after the war ended, which revealed whether his revolution represented merely wartime emergency measures or fundamental change in industrial capability. Traditional analysts expected the wartime shipbuilding boom to collapse immediately, leaving tens of thousands of workers unemployed and hundreds of costly facilities abandoned. The prediction proved partly accurate. Liberty ship production ended in September 1945 with the surrender of Japan. By December 1945, Kaiser's workforce had fallen from 200,000 to fewer than 20,000. The Richmond shipyards that had employed 100,000 workers at their peak stood largely empty by spring 1946. The boom towns that had grown around shipyards shrank rapidly. Yet the knowledge developed during the emergency program did not disappear into historical footnotes. The prefabrication techniques, welding procedures, and parallel assembly approaches that Kaiser pioneered became standard practice in global shipbuilding, adopted by every nation that sought to rebuild maritime industries after the war's destruction. When Japan and South Korea rebuilt their maritime industries in the 1950s and 1960s, they studied Kaiser's Liberty ship program extensively and adopted his approaches as the foundation of their yards. The massive shipbuilding facilities in Ulsan, South Korea, and Nagasaki, Japan, that would dominate world shipping, construction for decades were direct descendants of Richmond shipyards' revolutionary practices. Korean and Japanese engineers who visited American yards in the 1950s returned home with detailed documentation of Kaiser's methods. The technological innovations developed during the Liberty ship program influenced industries far beyond maritime construction in ways that shaped modern manufacturing across sectors. The welding techniques refined under wartime pressure became standard in structural steel construction, petroleum refining equipment fabrication, pressure vessel manufacturing, and pipeline construction. The prefabrication approaches pioneered at Richmond influenced construction practices in housing, where entire wall sections could be built in factories and assembled on site, bridge building, where deck sections could be fabricated and lifted into place, and industrial facilities, where modular construction reduced on-site labor. The organizational principles of presse-de-motte, parallel production, simplified specifications, and rapid worker training became foundational concepts in operations management and industrial engineering education, taught in universities and business schools as examples of revolutionary thinking. The magnitude of Kaiser's achievement can be measured in statistics that reveal both the scale of the program and its remarkable success that exceeded even optimistic predictions. Production statistics show 2,710 Liberty ships built across 18 American yards between 1941 and 1945, an average of 1.8 ships per day at peak production. Kaiser's 7 yards alone produced 1,490 ships, comprising 55% of total Liberty ship production. Construction time fell from an average of 230 days for the first Liberty ships in 1941 to 42 days by 1943, with the record holder, Robert E. Peary, requiring just 4 days and 15 hours from keel laying to launch. The battle casualty rates among Liberty ships demonstrated their effectiveness despite skepticism about rapid construction approaches and welded hulls. Of 2,710 Liberty ships built, approximately 200 were lost to enemy action, a loss rate of 7.4%. This compared favorably with pre-war merchant shipping loss rates and proved that welded construction, while initially suspect among traditional maritime engineers, produced seaworthy vessels fully capable of surviving combat conditions. Some ships experienced structural failures due to welding defects and steel brittleness in cold water, problems that were identified and corrected. 3 Liberty ships broke completely in half due to brittle fracture problems in 1943, representing 0.11% of production. These failures led to improved welding procedures and steel specifications that eliminated the problem by 1944. Longevity statistics provided the ultimate vindication of Kaiser's construction approaches that skeptics had claimed would produce vessels barely adequate for emergency service. Liberty ships, designed as temporary vessels with expected service lives of 5 years, proved remarkably durable, exceeding their design specifications by decades. Many remained in service for 30 or 40 years after the war. The SS John W. Brown, built in 1942, remains operational as a museum ship in Baltimore as of 2024, 82 years after construction. The SS Jeremiah O'Brien, also built in 1942, is preserved in San Francisco and participated in the 50th anniversary commemoration of D-Day in 1994, actually sailing to Normandy under its own power after 52 years of existence. These vessels stand as permanent testimony to the quality of Kaiser's supposedly crude emergency construction. Admiral Chester Nimitz, commander of the Pacific Fleet, reflected on the strategic impact of American maritime production in his post-war memoir published in 1960 with the perspective of someone who had commanded operations dependent on logistics. Nimitz wrote with characteristic directness, "We fought across 5,000 miles of Pacific Ocean, supplied by ships built faster than the enemy could sink them. Japan's military planners assumed American industrial capacity was impressive but finite. They believed that if they sank enough ships, eventually American logistics would collapse and we would be forced to negotiate peace on terms favorable to Japan. They failed to account for Henry Kaiser and American industrial mobilization. By 1944, we were replacing shipping losses faster than Japan could inflict them even during their most successful operations. The mathematics of attrition favored the side that could build 3 ships daily over the side that could sink 1 ship daily. Industrial capacity, not martial valor or tactical brilliance, determined the outcome. The Pacific War was won in the shipyards of Richmond, Portland, and Baltimore, as much as on the beaches of Iwo Jima and Okinawa. In the end, Kaiser's greatest achievement was not the 1,490 ships his yards produced or the records his workers set, but the transformation of what entire industries believed possible about human capability, production speed, and organizational innovation. The Robert E. Peary, built in less than 5 days, stood as tangible proof that tradition did not equal truth, that conventional wisdom could be questioned and overcome, and that revolutionary improvement required revolutionary approaches, willing to challenge fundamental assumptions. The maritime establishment that dismissed Kaiser as an ignorant outsider in 1940 spent decades after 1945 studying and implementing his techniques while confronting the uncomfortable reality that their expertise had blinded them to possibility. The story of how Liberty ship construction time fell from nearly a year to less than a week is ultimately a story of transformation through courage to challenge accepted limits and faith in human potential when properly organized. It proves that the greatest revolutions often come from those unconstrained by tradition, that progress requires questioning accepted limitations, and that human capability exceeds conventional expectations when challenged and supported. Kaiser's workers were not superior humans, blessed with extraordinary talents. They were ordinary people, farmers and housewives and young people without experience, achieving extraordinary results because someone believed they could and organized systems that allowed them to prove it. That lesson, demonstrated in the shipyards of Richmond and validated by thousands of completed vessels, remains relevant wherever industries face challenges that conventional wisdom claims impossible. The Liberty ships are mostly gone now, scrapped decades ago, or resting on ocean floors. But the revolution they represented endures in every modern shipyard, in every manufacturing facility that uses prefabrication, in every training program that teaches specific skills quickly rather than broad expertise slowly, and in every manager who questions whether impossible truly means impossible or simply means nobody has figured out how yet. That is Henry Kaiser's enduring legacy, carved not in steel, but in transformed understanding of what dedicated people can accomplish when freed from the constraints of tradition and challenged to attempt what experts claim cannot be done. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.